In this video, we will use the equation 8y squared minus 2y equals 1, and we will want to solve it. We will solve it ultimately using the quadratic formula in part B. But before we can do that, we need to answer part A. So in part A, we are asked what are the values of A, B, and C? Well, before we can answer that question, we need to make sure that our equation is set equal to 0. So we'll take the equation 8y squared minus 2y equals 1, and we'll set it equal to 0 by subtracting 1 from both sides, giving us the new version of the equation, 8y squared minus 2y minus 1 equals 0. You never want to identify your a, b, and c values until your equation is actually set equal to 0. You should notice by having moved the 1 from the right side over to the left side, it is now a negative 1, and we need to have the correct sign on each of the values. So for our particular equation, our a value is 8, our b value is negative 2, and our c value is negative 1. Now that the equation is set equal to 0 and we have our a, b, and c values, now we can solve the equation using the quadratic formula. While we do typically state the quadratic formula as x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, we do want to be particularly careful to make sure that the variable in the equation matches the variable that we're solving for. What I mean by that is that our equation has 8y squared minus 2y minus 1. There are no x's in the equation, and as such, our quadratic formula should not say x equals, but in this particular case, it needs to say y equals. And now that we have the quadratic formula set up for our particular equation, we need to substitute in 8 for a, negative 2 for b, and negative 1 for c. So our quadratic formula as we start to solve will become y equals the opposite of negative 2 plus or minus the square root of quantity negative 2 squared minus 4 times 8 times negative 1 all over 2 times 8. I want to explicitly point out the parentheses around the negative 2 in the front, where we have the opposite of negative 2, and the parentheses where that negative 2 was squared are critical. Leaving out the parentheses, especially where that negative 2 is being squared under the radical, if you leave out the parentheses, you fundamentally change what it is you're trying to say. We need to square both the negative and the 2, and so therefore the parentheses are necessary. Continuing on with our simplifying at this point, there are 3 things we're going to do as our first step. First, I'm going to simplify in the front the opposite of negative 2. The opposite of negative 2 is simply a positive 2. The next area to simplify is underneath the radical. So we're not going to adjust or manipulate the radical, but negative 2 quantity squared is a positive 4, and negative 4 times 8 times negative 1 is a positive 32. And the final step of simplifying that we'll do is down here with the 2 times the 8. 2 times 8 is 16. The more comfortable you become with the quadratic formula, the faster you'll be able to do the arithmetic simplifications that you need to do to finish the work. The next step will be to combine what is under the radical. So we'll end up with 2 plus or minus the square root of, we had 4 plus 32, but 4 plus 32 is 36. And so we end up with 2 plus or minus the square root of 36 over 16. Bringing that back up top to give us some more room here, we have y equals, well, this radicand is a perfect square under that square root. So 2 plus or minus the square root of 36 can simplify down to 2 plus or minus 6 all over 16. One of the things you'll start to probably find somewhat interesting about the quadratic formula is the cleaner the square root, the more work you have to do. Often the messier the radical, the sooner you can stop your simplifying process. But in this case, to finish finding the solutions, where we have y equals 2 plus or minus 6 all over 16, here's a place where we do need to separate this into the 2 possibilities and work each one individually. So one possibility is that y equals 2 plus 6 all over 16, and the other possibility is that y equals 2 minus 6 all over 16. Just like when we used the square root property, we ended up with a positive or negative radical. Again, there is a direct connection here. That's what we have built into our quadratic formula, a positive and a negative radical. Simplifying the left option, y equals 2 plus 6 over 16. 2 plus 6 is 8, and 8 over 16 is 1/2. Over on the right side, simplifying 2 minus 6 over 16. 2 minus 6 is negative 4, and negative 4 over 16 is negative 1/4. So again, we do get two solutions, one involving a positive square root and then one involving a negative square root. And we can conclude with our quick solution set notation statement. The solution set is the set 1/2, comma, negative 1/4. Like with any equation, we can check our work by throwing the 1/2 back into the y's in the original equation, or the negative 1/4 in for the y's in the original equation. Given the fact that we have fractional answers, or we're starting to get messier answers even than that, I would definitely make use of a calculator to do a lot of this checking.